So we're going to calculate the following improper integral, and the thing we always do first is turn it into a proper integral. When it's the bottom limit, I do like to use a, upper limit I like to use b, but you really can use anything except for don't use the variable that's already in there. So we got a to 0 of e to the x over 1 plus e to the x dx. And so right now we're going to concentrate on just the definite integral. We'll do the limit after we've done our fundamental theorem. So I'm seeing this as a U substitution because I'm going to let u be the bottom, 1 plus e to the x, and therefore my du, and derivative of 1 is 0, derivative of e to the x is e to the x dx, and my du is actually right there. So I've got limit as a approaches negative infinity, and I've always been a big fan of swapping the limits so that I don't have to change back later. So an upper limit is 0, plugging 0 in there. E to the 0 is 1 plus 1. This new upper limit becomes 2. Lower limit's going to become 1 plus e to the a. What I'm doing is I'm taking these x values, plugging them in for x to get what the u values are for the limits. This actually just simplifies to du over u, and now I don't have to sub back. My antiderivative in this case is actually one of our basic ones, and it turns out to be just natural log of the absolute value of u. And you don't really need the absolute value. Both of our limits are going to be positive. So 1 plus e to the a and 2 are our limits. So we are going to have ln of 2. Let's rewrite that because I want to have the limit up front. Limit as a approaches negative infinity of the natural log of 2, which is just a number, minus the natural log, again you don't need the absolute value, but 1 plus e to the a. It's not going to make it wrong to have it in there. This part does not depend on a. So the question is what happens here as a goes to negative infinity. Well, as a goes to negative infinity, I'll write this over here as scratch. As a goes to negative infinity, e to the a goes to 0. We're thinking of that exponential function, right? As we go to negative infinity, it goes to 0, which means this part here actually goes to 0. Natural log of 1 equals 0, so this limit is actually equal to ln of 2, so this guy converges to the natural log of 2.